Okay, 3 equations to solve for your values of A, B, and C. I'll use my values. 2 things I want to illustrate with these 3 examples. One is, I think everybody's pretty good with this, but we'll work it through just to make sure we understand the operations. Okay? This one, you got denominators in an equation. Multiply both sides by a common denominator, and then you don't have denominators anymore, and it's easy. Okay? This one, recognize it as a quadratic equation, and if you can factor it, great. If you complete the square, I'm impressed. But generally, in the real world, you're not going to have nice numbers, and you're going to use the quadratic formula. Okay? So you got to know the quadratic formula. 2 things. Know the quadratic formula, know to multiply both sides of the equation by a common denominator. Things that I tell people at this stage of the course they got to do, and they never remember. Be different. Okay? Do it right. Okay? So let's just see how it works out. Everybody did pretty well with this one. In my case, let's see, this would be 5x plus 4. I'm trying to remember my name. Equals, I'm going to use a different number. That's not really my number. 7x plus, I'm going to use 15. Just because I don't want to get 1s. Okay, I'm going to get some 1s if I get those. It's not as illustrative. Okay, so there's the equation I'm going to solve. Well, what do? Well, now, you all want to write minus 4 here and minus 4 here and do that, and that's fine. I'm not going to write it that way, and I'm never going to write it that way. Because you have to be able to write equations out linearly. So, to make it very explicit what I'm doing, same thing you did or would have done, but actually written out so you can read an equation rather than something else. I don't particularly like that style, but I can't really object to it because it seems to work just fine. But this is the way I'll write it out, and I want you to be able to write it out this way. If I don't ask you specifically to write it out in linear form like this, showing explicitly what your operations are, it's okay to do what I've seen everybody do. Okay? But if I ask you to show it this way, you got to show it this way. None of this minus 4 and then so forth. Again, no objection to that, but you got to be able to also do it this way. Okay? Okay, so then we're going to do 5x minus 7x equals 7x plus 11 minus 7x. I'm not going to make you go through the whole associative and commutative rearrangement of this. We know we can rearrange these terms, these pluses and minuses, in any order we want. Okay? So I'm going to not get too picky with that. I'm going to get negative 2x equals 11, right? And then I'm going to write negative 2x over negative 2 equals 11 over negative 2, so that x equals negative 11 halves, or negative 5 1/2, or negative 5.5. I want the rational expression. That's your official solution. These are equivalent solutions. Okay? And a lot of times, if this is 11 over 3, you wouldn't be able to write it as a decimal. Okay? You write it as 3 2/3. That'd be okay. But mixed numbers are pretty useless for doing actual algebra. Okay? They're useful for positioning a point on a graph. Okay? Well, where's 11 halves in a graph? It's a lot easier to find 5 1/2 or 5.5. Okay? But you can't write a decimal that's exactly equal to 5.5. Well, you can. It's 5.33 repeating, right? I'm sorry. It's, yeah. If it was 3 2/3, 11 thirds, would be 3.666 repeating. You'd probably round it off to 6, 7 and say it's an approximation. If you approximate, you've got to make sure you say you've approximated. Okay? And you would approximate in order to put it on a graph, right? You don't need all those 6s to figure out about where that thing goes on that graph down to within, you know, a pencil point. Okay, anyhow, there you have it. So that's straightforward. Everybody did this or something equivalent that I saw, okay? You know to subtract the 4 from both sides, subtract the 7x from both sides, then you get all your x's on one side, all your y's on the other side. And you didn't do it by magic, you did it by valid procedure. Okay, might not have looked exactly like this, but you're pretty good there. Okay, so I think we're good with these. Now let's take x over, I'll use 5, plus 4 equals x over, in my case I had 15 of all things. So pretend I got 15 letters in my last name, okay? Smith-Arrhenius or something like that. Okay, so what, common denominator, could be 5 times 15, that's 75, right? There's a perfectly good common denominator, probably not the easiest one to use, although it would work just fine. There'd be no problem if you multiply both, every term in the equation by 75, okay? But there's a smaller common denominator, what is it?
15.
Sorry?
15.
Yeah. Okay? So you can find a smaller common denominator than the product of all the denominators, by all means do it. In other words, use the least common denominator if you can find it. And you should be able to do that with a little bit. Okay, so we multiply every term by 15. Okay? Because you're multiplying then both sides by the same number. If you multiply both sides by 15, you're multiplying every term on both sides by 15 by the distributive law. So, you do 15 times x over 5 plus 15 times 4 equals 15 times x over 15. Now I'm not going to go through the fractions. I've been through how you multiply fractions, a number times a fraction, or divide a number by a fraction, okay? And I'm not going to talk any more about it. But you need to do it correctly, and if you start doing it incorrectly, I'm going to probably, on an individual basis, give you a little supplementary stuff to look at. Okay, so 15 times x over 5 is what?
3x.
3x, yes, you have the 3, but you didn't have an x. Get 3, and I don't know how
to be
you,
quiet
if
back
you're
here.
flexible enough, you cross your
I'm
fingers.
trying to be quiet back here.
Okay.
Give somebody else.
It was good, good answer. I knew what you meant.
Somebody else.
Plus 60 equals x, right? Now we're not done, but we can easily finish at this point. And you see that this is a lot easier to look at than this, right? Now we'll have people, and it's valid, put everything over a common denominator here, and then do the fractions, okay? But it's easier just to clear your denominators by multiplying by the common denominator, because you get into the fractions, you know, fractions are undertaught. It's very easy to make a mistake when you haven't used them that much. So get rid of the fractions if you can. You can't always do that, probably. There's your strategy. Now the other one, the quadratic. Okay, this, in my case, this would be x squared plus 5x plus 15 equals 0. I should have made that minus, okay? Because then I'd know there was a solution, but I'm going to do it with a plus. Just remind you. Okay, so There's your quadratic formula. If you forget it, Google it. You'll see it 48 million times in the first tenth of a second. Okay? I could have written it bigger. Some of you are starting to see it a little bit, but it's something you should know. So, I'll write it again a little bigger. These two solutions, one for the plus, one for the minus. Again, something you should be very familiar with. You're just rusty, okay? Because I know you did this, and you passed the necessary courses, so I assume that all you need is a quick review. If you need more than that, we'll see. Again, I can give you references, but this usually suffices if people will memorize the thing. And you memorize it by using it, so I'll probably give you several equations to do. Okay? Just so you use it a bunch of times, and if you use it a bunch of times, then you're going to remember it. Be more likely to remember it. Okay. So, what's the value of A?
1.
Well, how do you identify A? A is what goes in front of x squared. And what's in front of x squared? Nothing, so A is nothing. No, it's the coefficient of x squared. Coefficient of x squared is 1 because you don't have to write the coefficient if you have a coefficient of 1. So A is 1. And B is what goes in front of x, and that's 5. And C is that number you got over here, and that's 15. So you get x equals -5 plus or minus the square root of 5 squared minus 4 times 1 times 15, all that divided by 2 times 1. Okay? And you end up with -5 okay? That's 25, and that's -60, so that's -35 over 2. Everybody see that okay? Okay, so what's the square root of -35? Well, this is one of the few places where you can use that forbidden instrument, your calculator, to evaluate the square root. Okay? And of course, it's -35. What can you tell me about the square root of a negative number? What do you multiply by itself to get a negative number? It's not a real number you can do that with. If you multiply 2 negatives, you get a positive. If you multiply 2 positives, you get a positive. So there is no real number whose square root is -35, right? So you got to use an imaginary number. Okay? And at that point, at this point in the course, you can simply say, well, that blind thing's imaginary. You say, it's going to give me a complex numbered solution. And that's all I'm supposed to say right now, unless you know. And if you know, go ahead and say it. Go ahead and write it out, okay? It's easy. You know. There's nothing to it. But we're not going to worry about it right now. We're just going to worry about if we got real solutions. Now, if you had a real, if that was plus 35, if I'd have put a minus in front of here, like I intended to do originally, then that would have been a -15, and the minus would give you a plus 16. You'd have 85. Square root of 85. Well, you'd have to write down what the square root of 85 is. You're probably going to approximate it. It's 8.1 to the nearest tenth. Okay? Now, actually, it's probably 8.2. Between 8.1 to 8.2. Okay? Because square root of 81 is 9. That said 9.1 or 9.2. okay? It said the square root of 81 is 9. Well, if it was 85, square root of 9, the square of 9 is 81, the square of 10 is 100. The square root's between 9 and 10, but it's a lot closer to 9, right? You can even make an estimate. So, you say, the point is, you say it's approximately equal to this. And then you work out what it is with the plus and with the minus. We'll see how you do with it. But it's going to be assigned. Okay? Let's review. Something you're supposed to already know. You've been through it. You've done them. Okay? If we find that you can't do them, well, then I'll suggest some materials to review it. Okay? And I'll do some examples, obviously.